So hello everybody, so I'm Adrien Gharios, I'm working for SCLE. And today I'm going to make a brief presentation about our safety platform and especially the way we use it and having some return on experience of the project we did with ourselves or with some partners. So first of all, I think it's a good point to know what is a generic platform, especially a safe generic platform depending on the standards. So a generic platform is a product that has a certification, and on the top of it we add an application. I'm sorry about that. And is not dependent on an application. So it's quite interesting to know that because afterwards we have some work to do to make an application to certify the application.
Adrien, parle bien mon micro.
Je parle, ok. So as you can see here on the standard, a generic platform is designed as something generic, and we add over it a generic application, which usually is a software where we get a generic application certificate, and over it, to make it a specific application, we also have to add another stack of development and of validation. For example, on our safety computer, we can see it here as a generic platform. We develop an application and we do some parameters to make it specific to the site. So what is the interest of using a safety platform compared of developing a product from scratch? So it's quite obvious that you can reuse a known and a proven SIL4 certified equipment. So when we start a new project, we can rely on what was already done, and we know the good points and the bad points of the products. We also can focus on the development of the application and not necessarily on the low-level software or hardware to design a new application. And also, it's quite important, we have an easier obsolescence management since the same equipment is used for several projects. So for example, we have an interlocking or whatever, we have several clients and we have to furnish this equipment for a really long time. Also, there is a major point to know that usually, when you speak about SIL4 or safety, we are saying we need a SIL4 project, but we really need to associate a hazard to the SIL level. It's really common to say, okay, we need to do something, a SIL4 project, and when we ask, so what is a hazard, people don't really know what is a hazard. So it's quite important because if you don't have the safety culture, it can be complicated to know what to do and to know what to plan. Also, a very important thing, and when you use a SIL4 platform to develop a SIL4 project, you still need a lot of qualification or a lot of expertise to make the application itself. It's not because you're using a SIL4 platform that you will succeed in doing a SIL4 project, especially depending on the hazards. Okay, on this slide I will present a bit what's the interest of having a SIL4 platform coming from the rail and not coming from the industry world. So first of all, it's what we did for the BGS. It was designed firstly for the SNCF, so we do respect all the constraints made by the Cahier des Charges GPS, so especially on the electric signals and all the characteristics asked by the SNCF to drive SIL4 signals, especially on the NS1 format environment. And that's also important because some operators have extra requirements, especially SNCF. For that, for our safety platform, because it's compatible with the NS1 signals and the safe signals, we don't need to use any relay as an interface. We don't need to isolate any signals. So for example, in a lot of projects using PLCs, you need to add NS1 relays or SIL4 relays just to avoid to have to keep the electric insulation of the system. Also on the safety platform, we decided to use some rail specified protocols. So, for example, on our safety platform, we are using right now the subset 98 protocol, the RBC to RBC protocol, and we can also go in a close feature into a Rasta protocol, which is designed for U-Links. So it's really interesting to use the standard protocols to have some interoperation between the equipments. Okay, just to speak about our safety platform. So our safety platform, BGS, is developed as a bare metal, so we don't have any OS, and the software which is developed on it is made in C language. So we can write the software by hand, so with developers, or we can also do code generation. So on some projects we did ourselves the software, and on other projects the software was generated from MATLAB Simulink and was done by partners. And also it's quite interesting to focus on that our safety platform doesn't need to have any relay interface or to get the signal, or also to drive lights, or to go on other safety systems. So for us, the business model we can propose on the BGS, we can propose 3 ways to work together. First of all, we can make the whole system on a specification. So we did that on several projects. So the client comes with a specification, and we do everything from the system specification to the SIL certificate. So we can work we already work with Certifair or with Bureau Veritas, and we can make the whole system on ourselves. And we take the responsibility to design it, all of it. We can also work as partnerships, so we can share the risk of the project. And we did that on our interlocking, where a partner did the whole system specification and the MATLAB Simulink design. They did the C language generation, and then we did the integration on our safety platform. And also we can sell the BGS as a COTS, so we can sell it to a client who gives a safety case associated to it, and the client manages all the certification itself. So here I will present the references we have. So all those projects are installed and are working. So our first project, sorry. Let me go back. It's not very important. So our first project, as you can see here, is a crosswind detector. So it was installed, it was designed for SEA, so the high-speed line between Tours and Bordeaux. And it's a SIL4 system using our safety platform, and we did the whole system design, the whole system production also. We produced all the cabinets, we wired the cabinets, and the only thing we did not do was the on-site installation. Our second project is the rain map, so it's a decentralized interlocking. So this was done with a partner, so we shared the risk and the development. So our partner was doing the system, designed, as I said, the system over MATLAB, and we got the C language, the C software, and we integrate the software on our platform. So this project now is working in Avignon, so it's SIL4 certified, and is in service since 2019. So another project also is quite interesting. We did a system for seamless mobility. So it's an in-railing verification system. So for the Neoval, they have a central rail which guides the train. So in the workshop, this rail is not present. So when the train is going out from the workshop, they need to check if the train is well in-railed. So on this project, we did everything ourselves. So from the specification to the certification. And we did it in 1 year, from the starting of the project and the SIL4 certificate. So we designed the sensors, as you can see here. We designed the software and also the cabinet and the wiring of the cabinet. And it was quite interesting to see that we can achieve a SIL4 project in 1 year using our safety platform. And the last project we are showing today is a vital interface computer, which is in use in Vienna. For this project, actually, we are selling our BGS as a real COTS. So we sell the computer with its SIL4 generic safety case, and our client is managing the software development and all the certification process. For this project, it's quite interesting also to know that it's an interface between the CBTC train, the Siemens CBTC, and our client is developing all the stack, the ANI stack, to get the command from the train to open the platform screen. So I don't know if you have any questions.